Hello everybody, in this video we are going to talk about how to solve systems of equations by graphing. When we're dealing with the system of equations, we're dealing with two or more equations that have the same variable and are graphed on the same coordinate plane. And then we have to determine what the relationship between those two lines are. So in this section, we are not only going to graph them, we're going to determine the number of solutions that they have. We're going to interpret their solution, and we should be able to explain when we have a system with no or infinitely many solutions. So when we're dealing with two different lines on our graph, there's only three possible solutions that can happen. You can have a no solution, which means they have nothing in common, no points in common, therefore they're parallel lines. You can have a one solution, which means that they intersect at one specific point, so that's the point that they have in common. And then the last one is infinitely many solutions, where it ends up being the same line and they share all of the points. They have all of the points in common with each other. So let's take a moment to look at what it actually looks like for a no solution, a one solution, and an infinitely many solution on a graph. All right, so as you can tell on this graph, you can already see that there's two lines that I drew that are parallel to each other. We can see that they're parallel and that they're not going to intersect. So this is what a no solution looks like. But we know that parallel lines do not intersect each other because they have the same slope. So before you say something is parallel or something is a no solution, you have to confirm that these two lines do have the same slope and that will not eventually intersect later off in a different part of the graph. So let's go ahead and take these lines right here that I created. I'm just going to walk you through them so I can prove that they are parallel lines. So when you're creating your own lines, you get to pick your own y-intercepts. I picked 0, and then my slope was going to be 2 over 1. So right here you can see that my graph went up 2 and over 1, up 2, over 1, up 2, and over 1. And I kept on doing that to create the rest of the lines, the rest of the points to create the line. From here I went down 2 and over to the left 1 and kept on doing that to create the other side of the line. Now for the second point, I picked my y-intercept -4 and then used the same slope. So notice that from here, I'm still going up 2 and to the right 1 to create the rest of these points. And then in the opposite direction, I went down 2 and to the left 1. So I can confirm that both of these lines are parallel to each other and therefore no solution to this system. So let's take a moment to look at what a one solution will look like. Now, one of the things that I do want to point back is that I did one or two things. I also labeled both of my lines, either line 1 and line 2, but you can also color code them as well. And so notice that I went back and added that M1, line 1, has a slope of 2, and then line 2, M2, has a slope of 2. And so I can see that both of these are the same. So when you notice that two lines are parallel and you prove that they are, then make sure that you also show me that justification. All right, so let's go ahead and talk about that one solution here. So when we are dealing with a one solution, you are still going to have two lines on the same coordinate plane. But the difference here is that we're going to have two lines that intersect each other. And wherever they intersect, that one point that they have in common is going to be the solution to our system, because that point exists on line 1 and that point exists on line 2, and that's what we're trying to determine. So I'm going to go ahead and write down some equations so we can graph them out and see that they are indeed one solution. Okay, so notice that we have two equations here. I've labeled them y1 and y2 to let you know which one is our first line and which one's our second line. So according to this is our y-intercept is -4. Our slope is -3 over 4. So let's go ahead and graph that one first, and then we'll color code it and then move on to the second one. So for this one, our y-intercept is here. And according to our slope, it's telling us to go down 3 and over 4 to the right. So I'm going to go down 1, 2, 3, and then 1, 2, 3, 4. Notice that I'm running out of space here, so I'm going to do the opposite, which is go up 3, but negative 4. So that means 4 to the left. 1, 2, 3, 1, 2, 3, 4. And I'm going to do that as many times as I can. Alright, so notice I have my line here. This is my first line, so I am going to label it line 1. I'm just going to put a little 1 here. And then we're going to do the same thing with y2. We know our y-intercept is 2. Our slope is 3 over 4, so that tells us to go up 3 and then over to the right 4. So let's find positive 2, which is here on the y. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Now, notice when I go in reverse. 1, 2, 3, 1, 2, 3, 4. This is the point that they have in common because this point originally was on our graph for line 1. Now I'm going to keep on going. I'm going to count down 3 and then go over 4. And then I'm going to connect these dots. So you can already see that both of these lines are intersecting. And when you graph this out, you're going to also notice which point they already have in common. So when we have these intersecting lines, it's not enough to say, oh, it's a one solution. We have to point out what that solution is. What is that point that exists on both lines? All right, so I went back and color-coded. I also went ahead and added that one solution are lines that intersect. And so we're going to see what point they have in common. So this point right here is negative 4, negative 1. So our solution is negative 4, negative 1. And so we're going to go ahead and take a moment to look at a line, our last type, which is infinitely many solutions. All right, so for infinitely many solutions, we're talking about the same line. The only way you can have more than one point in common with a line is if they're exactly the same. So you're going to see that sometimes you're going to have equations that don't initially look like they're the same line, but once you either solve it, simplify it, or pull out the slope and the y-intercept, you will be able to tell, wait, this is the same line. So it's one line on top of the other. So for this one, let's go ahead and graph it out. We have b is equal to negative 6, and our slope is going to be 4 over 3. So let's go ahead and graph line 1. Notice that I labeled it, and I'm going to either label or color code or both. So from here, let's start at negative 6. We're going to go up 4 and to the right 3. So 1, 2, 3, 4, 1, 2, 3. And then we're going to keep on going up 4 and over 3 until we run out of space. And notice that I don't have the room to go down 4 and over to the left 3. So these 3 points are just going to have to do it. So let's go ahead and connect it. This is line 1. And so for line 2, we can see that the y-intercept, notice that they flipped it, is still negative 6. Our slope is still 4 over 3. So if I try to go back and do that, I'm just going to recreate the same line because here's my y-intercept, here's the slope, and the other points. So it's basically both line 1 and 2, one on top of the other. So what I'm going to do when I color code this is I'm going to do one side in green and then the other side of the line in blue to represent that they're both there. So just a quick review of everything that we did. So we talked about the 3 different types of lines. We know that if we have a no solution, it's because 2 lines are parallel and they have the same slope. If we have a one solution, it's because both lines intersect, and at that one specific point is our solution. And then the last one is we have 2 lines that are exactly the same, one on top of the other. They're the same line, and therefore they have infinitely many solutions because it's not just these 3 points that they have in common. It's all the decimals and fractions in between. All right. I hope that helped, and then I'll see you guys in the next video.